It's the last session of the day, and I'm very thankful that you're here. It's been a long day, I'm sure, so thank you very much for attending this talk. So this is about using RAG and LLM to streamline the Drupal string translation. Let me quickly introduce myself. So my name is Mori Sugimoto. So my username on Drupal.org is Mori, and I've been using Drupal since 2006. And I'm originally from Japan, and now for the last 9 years, I've been based in the Netherlands. And actually, Miffy, or Nijntje in Dutch, is also from Utrecht, so I feel at home. So if I start to feel stage fright, then maybe I'll carry it around and get some moral support. So over the last 2 decades, I've used Drupal quite extensively and worked with various clients across Europe, Japan, and the US. And while I've moved into more product-focused role in the last 5 years or so, I still enjoy building technical solutions to solve real-world problems like the solution that I'm presenting today. And also, just to mention that I'm currently looking for new projects, so if you are in need or interested, please reach out. So that's me. Okay. So first, I'll briefly clarify the challenges of translation, and to be honest, there are lots. There are a lot of challenges in translating Drupal strings into another language, and I'm focusing on a certain aspect with this project. And the second part is about how this project came to be, and then I'll explain about the actual tool and give you a very quick demo. And then I'll talk about the components, architecture, and logic, what's under the hood, how it works. And it's more than just a translator or translation tool. So the additional features that are available, I'll also touch on that. And then caveats on how to use this effectively and what's next. So the challenges of translation. If you have ever involved in the translation of Drupal strings, by the way, any of you involved in Drupal strings translation? Okay, a few. All right, thank you. So I'm sure you know it, but simply put, it's hard. It's hard enough to translate English into any language, but especially to languages that don't belong to the Indo-European linguistic family. Like Japanese is like so different, so that makes it extra hard. And regardless of the target language, it's really time-consuming to ensure the translation flows well. For example, when I translate from Japanese to English to Japanese, it sounds a bit awkward, and I need to massage it a bit to make it sound natural. And also, maintaining consistency is difficult. So you need to follow the certain style, and you need to make sure that certain terminologies are translated correctly, and so on. So these are the challenges that I want to address with this tool, and RAG and LLM as a solution. So where it all began. So at DrupalCon Nara that took place last year in November, it was a lovely event. And at the contribution sprint, I approached some community members and suggested that maybe we can use LLMs to translate Drupal strings. And some of them were active translators of Drupal strings and documentations, and they were interested. So we sat around the table. That was a round table, so we had a proper round table discussion. Around 10 people from the community, and we did a brainstorming. But we weren't really sure how best to proceed. And we were discussing like, can we maybe run it on our laptop, or and how do we make all the translations consistent? Do we maybe pick a model and fine tune it? And we couldn't really come up with, decide on a direction. So we decided to set up a project page and explore possible solutions and share findings in the threads. And around the same time, I reached out to Amazy.io if they could provide their LLM resources by any chance for this project. And generously, they provided the resources for this project. And they also advised us that RAG may be the right approach. So I started to look into it. So many thanks to Amazy.io and Amazy AI for the resource and direction. And RAG, to be honest, so in November, I didn't know what RAG was. And Matthew Sanders at Amazy.io mentioned about RAG, so I started to look into it. So, so just to mention that I'm not an expert. I've only been playing with it for the last 6 months or so, or less. But in simple terms, it's a technique to reduce hallucinations and improve accuracy of LLMs. And think of Notebook LM as an example, if you've used it. And also, all the people in the Drupal community I've talked to in the last 4 months all knew about RAG. So I thought maybe I don't need to go into the details here. So I kind of omitted all the details. But Vincenzo Gambino did a great talk earlier today. So if you want to know a bit more about it, then I'd highly recommend his talk. So let me give you a quick comparison between LLM translation and RAG and LLM translation. So if you translate strings or text without RAG, you basically pass the original untranslated text with a prompt that says maybe like this is Drupal UI string, so translate with Drupal terminology and and so on. And then you pass that onto the LLM, and then you get the translated text. But you don't know if the LLM translates Drupal terminology correctly or if the style matches. So it's a bit of a hit and miss. And with RAG, you can provide context. So when translating the word publish into Japanese, it can be translated into a few different words. And by leveraging RAG to supply relevant context, we can enhance the accuracy of translations by LLM. So that's the one that we want to use for Drupal UI. So when you publish a page, for example, that's the word that we want to use in Japanese. So when you use RAG, so you have the original untranslated text, and then the system queries the vector DB, so and grabs the context that is semantically closest to the original text, and then you combine those with the prompt and then send it to the LLM. So LLM has better information to work with, and as a result, you get a correct translation most of the time. Not all the time, but most of the time. And the RAG and LLM translator has been shown to consistently outperform LLM-only methods. And with RAG, the accuracy and accuracy and context adherence is superior. Or I would not be here to be talking about this. Okay, and the scope of this tool, the RAG LLM translator, is not it's not intended to automate the entire localization workflow. because of the manual approval process on localized.drupal.org, the translation workflow of Drupal strings cannot be fully automated. And I also think that it's important that we have a human in the loop to check the quality. So the full automation is out of scope of this project. And this is a tool designed to augment your existing workflow and reduce the burden. So the overview of the RAG LLM translator. By the way, I'm horrible at coming up with really cool creative names, so it's really straightforward. If you have if you can come up with a good name, please do let me know. Okay, and I just want to quickly share how it evolved over time, or it's a brief history of over-engineering. So at first, I had this minimal and clunky proof of concept, and I just wanted to try out and see what how well RAG works. So I built this everything hard-coded, really simple proof of concept, and it was convincing. So I wanted to share this with the community members who were involved in the discussion. So, and it was just too too difficult to set it up locally. So I made it easy to run. So I added some setup script and things like that to make it easier to run locally. And this is when the first round of many refactoring took place. And then I thought, well, this can actually be useful for communities outside of Japan. So I made it multilingual, and then I thought, well, actually, this can be useful outside of the Drupal community. So so it's basically useful for any get-text compliant applications. So I made it to accept custom prompts and made fine-tuning of RAG easier. And then it was really fun working with this. So I was like, okay, well, let's add more features. And I added glossary extractor, post-processing plugins, and I just went wild and had great fun. But it's still a proof of concept, and I'm accepting feedback and willing to improve it, or even possibly discard this and take an alternative approach. And also, I think it's important to mention that share this upfront, that I built it with AI. It's not like I was away for dinner and when I came back it was done. Like I mentioned earlier, it was very much an iterative approach. So, and I also adhere to the mantra that Dries suggested, which is never submit code that you don't understand. So I did a thorough code review. I pretty much reviewed every single line and validated the logic. And also did a lot of refactoring because AI, unfortunately or fortunately, doesn't do everything right. So it's been a very long iterative process to make it work properly. Okay, so before running the translator, you need to do some one-off tasks. So, of course, you need to clone the repo, and then you need to run an initial setup script. You basically you supply the LLM's API URL endpoint or your API key, or set the target language, things like that. And then once that's done, you need to populate the vector DB, because without it, it's just a straight LLM translator. And then, so the vector DB needs to be populated with glossary and or translation memory. And translation memory is basically what you already have, which is the existing translated strings, which can be obtained from localisedrupal.org, or there's an export of translations are available via FTP, so you can grab those as well. Okay, so let me show this demo. So live demo is always a bad idea, so I decided to record it. And also, it takes about 10 minutes, and all you can do is just watch the log, streaming, and it's not the best use of our time. So, okay, so this shows that I ran this. I don't know if this works. Yeah, so I ran that command to see if the vector DB is populated. And there are two collections, apptm, that's for translation memory, and there's about 8,000 records, nearly 8,000 records, and then app glossary, so we have 650 glossaries, so it's ready to go. So, okay, so I'm running the translation script, and then it shows you all the available models, and you can supply your JSON to override this. And then I also chose, so there are two modes, with RAG or without RAG, and I chose with RAG. And this is log stream that you're seeing, and then you can see what's being sent to the LLM. And then also you see the result of, it's very quick, so it's hard to catch, but you see some shield icons, which are basically rejecting the context that were retrieved from the vector DB because it wasn't close enough. And then once it's done, you get this message saying translation workflow complete. And then here it says, I'll touch on this later, but there's this post-process framework, and if your language has some specific requirements on how things need to be formatted, you can use like your custom plugin to make that alteration, because LLMs can't do that reliably. And yeah, so the file is saved here. By the way, I started running this process with, in the demo, I chose Claude Haiku 3.5, but it says dry run because I didn't want to run the whole process, so I kind of swapped it. But yeah, there's dry run as well to see, so that you can see how it works without burning tokens. Okay, and you might wonder what the quality is like. And initially, I checked the results manually, and I was convinced that it was working really well. But because of the number of strings, so for the development and testing of this tool, I used a PO file that contained 1,300 untranslated strings, and I was trying out like 5-6 different models, and it's time-consuming to check manually, and it's really difficult to prove its effectiveness in a statistically valid manner. So I added an evaluation feature called LLM as a judge. And basically what it does is it performs blind A/B tests to compare RAG versus non-RAG translations. And it only checks strings with valid context, because it's no use to check if there are no valid matches. It scores from 1 to 5. 5 is the highest, and LLM gives detailed reason for each decision, so you know exactly why it was scored high or low. And there are two outputs, output files. So one is in CSV. It has this granular scores and the judge's reasoning for every string. And the other one is a summary report. So it summarizes, calculates win rates and performance metrics and so on. And this one is an excerpt from the CSV. So at the top, this is the untranslated text that was translated by LLM. And below RAG context, so one from glossary is configure, from translation memory, allow settings. And with RAG, this was translated based on the above three strings. And without RAG, it was translated just with the untranslated string and without the context. And this is what the judge says. So currently, so with RAG, correctly reflects the glossary by translating configure as blah blah. And so fluency is 5 and RAG context is 5. And without RAG, it fails to use the glossary term for configure, translating it as blah blah blah. So it gets a fluency score of 2 and RAG context score of 5. So for each of the strings that it checks, it gives you this evaluation and the score. And this is the first half of the summary report. So it shows you when it was conducted, and it shows you the judge model. And so you can use any of the models that are available for as a judge. And so this, and here I have 2 files. So with RAG, I have, so for with RAG and without RAG, I used Mistral. And then I used Kimi K 2.5 as a judge. And total evaluated is 296. I'll come back to this number. And the wins are, wins with RAG is 116, wins without RAG is 34, and ties 146. So you can see that it's with RAG, translations with RAG gets higher score. And this 296, this number, So where this number came from is it's from this thing called Cochrane's formula. I don't know if you are familiar with statistics, but so basically Cochrane's formula, given the sample is randomized well, regardless of the sample size, so in my case, sample size was 1,300, but even if the sample size is, let's say, 100,000, you only need to test up to about 334 samples in order to evaluate at 95% confidence level with plus or minus 5% margin of error. So, and it didn't really, I didn't really understand this, to be honest, at first, and I searched for some explanation, and what helped me understand it was this analogy. So let's say you have a recipe for a soup, and it gives you a list of ingredients, but it only shows you the ratio. And regardless of how much soup you make, so in a small pot for 2 people or in a massive pot for 100 people, given that the soup is mixed well, so is randomized well, the taste of the soup should be the same. And I thought, okay, well that's easy to understand. So based on the Cochrane's formula, since I have 1,300 samples, so it's sufficient. So 296 is enough number of strings to test to evaluate at the 95% confidence level with 5% plus or minus 5% margin of error. And this is the bottom half of the summary report, and it shows you comparative metrics. So versus non-RAG, it shows you 3.41 times more likely to win, and all the positive numbers to show how effective it is, and comparison of the scores at the bottom. And the QR code here is a link to the thread where I shared with the people in the Japanese community 2 sets of the test results. So, and I've attached the summary report and the detailed information on the how it was judged, and the translations that were produced with and without RAG. So if you want to look into it in more detail, you can look at those files. Just so you know, I've updated the code since I posted it, so it looks different. If you run it now, the report looks different, but the idea is the same. So let me get a quick sip of water. Okay, so now let's look at what's under the hood, so components, architecture, and logic. And I want to give you a quick overview of the components, so it would make more sense when you look at the architecture diagram. So I use Docker Compose for the infrastructure, LLM, any OpenAI compatible API endpoints, and also for get text and file handling, I used this Python library called GPT-PO Translator. And for vector engine, I used ChromaDB. Text embedding model, I used BAAI, BGE large, EMD 1.5. I've tried some other models, and this turned out to be the best. I'll touch on this a bit more later. And orchestration is handled by the custom RAG proxy. And refinement, this is an optional final layer. It's a custom post-processing framework. Okay, so GPT-PO Translator is, it actually translates PO files using LLMs, and it also offers robust get text support. The reason why I didn't use this for translating for the Japanese strings is that it lacks support for external context. So you can't just plug RAG into it and then add context. So in this RAG LLM translator, its primary function is handling files and get text, and also batch processing. By default, it grabs 15 strings from the PO file, and then send them all to the LLM with the context. So ChromaDB, it's a knowledge base, so stores the project's shared context, so glossary and translation memory, and then the RAG proxy does similarity searches to find contextually related strings rather than exact keyword matches. And this BG large ENV 1.5, it's a text embedding model, and it offers high dimensional mapping, so it transforms text into 1024 dimensional vectors. To be honest, it didn't make sense to me when I first saw it, but basically, so when you give a piece of text to this text embedding model, it converts, it gives you 1024, like it's an array of 1024 values, and you don't know what each one represents. So the idea is that one label is like, is this food, or this is like purple, or this is about Drupal or something. You don't really know what each number represents, but then it gives that array, and then that's, so with that, the term is, or the string is mapped inside the semantic space. And similarity distribution, this was really important when I was looking for the right model. So I used, I tried this one called intfloat multilingual E5 large, and but the data clustered so closely that even though some words were just completely different, they still clustered so closely that it was really hard to filter. And this model's version 1.5 was specifically trained to solve that clustering issue. So it works much better than the other model I tried. So next, the custom RAG proxy. So it fills the context gap. It provides RAG support, which GPT-PO translator lacks. So GPT-PO translator in this system, it thinks that it's talking to an LLM, but it's actually talking to the RAG proxy, and the RAG proxy as the context, and then send requests to the LLM. So it does the interception, and yeah, and also it reduces API costs, because in theory you can just stick all your glossary into your prompt, but then you'd be sending that with every request, and you can burn your tokens quite a lot that way. With RAG proxy, it only grabs up to two strings from the vector DB and attaches it to the request. So it's much more cost efficient. Okay, and this post-processing framework. So this allows application of language-specific modifications to translated strings. So this works after the translation with the LLM happens. So, for example, in Japanese, it's encouraged to, so this is a string in Japanese, but if you look at it closely, there are white spaces between the multi-byte characters and Latin characters. So this is encouraged because the Japanese fonts are generally chunky, whereas Latin fonts or letters are narrower. So it looks squashed and harder to read. So this is considered the best practice. But if you tell an LLM to do this with your prompt, it doesn't do it reliably. So I added this post-processing framework, and you can add any rules. Like if you if your language has certain requirements or best practices, you can just build your own and add to it. Oh yeah, okay. And then next is the architecture. So I've already touched on this a bit, but so it's a three-stage process, and the first stage is this is not something that you need to do before every translation. This is one-off-ish, unless you get new translation memory and glossary. You run it before you run it for the first time. And you ingest the translation memory and glossary into the vector store, which is ChromaDB in this case, and then you're done. It offers, this tool comes with a script to ingest translation memory, so and glossary, so it's really easy to do. And the second stage is the the second stage is the actual translation, which I showed you earlier in the demo. So you first you place your PO file in the designated folder, and then run the command. And GPT-PO translator grabs the strings from the input, from the PO file, and then pass it on to RAG proxy. RAG proxy then queries ChromaDB and grabs context, and then combine that with the prompt, and then send it to the LLM, and you get a response that gets written into a new file. And after all the translation of the strings is complete, then it goes into the third stage, which is post-processing. And this is optional. If you don't need to do any post-processing, then you can just disable all the plugins. But if you do enable them, this is where it runs, and you can change the order of which plugins run in what order. And then at the end, you get this final, clean, nice PO file as the final output. And as for the logic, I'm going to cover the RAG distance and thresholds here. So in this system, I'm using cosine distance, and there's a couple others, but for example, Euclidean distance doesn't work very well in this for this use case, because the length of the string will affect the similarity decision. So I use cosine distance for this, and in general, so 0 to 0.2 is, it says near identical, but 0 means literally identical. And up to 0.2, around 0.2 is near identical, so it's safe to accept these. And the sweet spot, 0.2 to 0.3, so these are paraphrasing, but it's safe to accept. And from 0.3 to 0.45, it starts to become a bit shaky. And from 0.45 onward, it's often unrelated. And for this system, after the analysis, I've set the threshold of 0.37 for glossary and 0.28 for the translation memory. And this comes with a tuning helper. So if you do a dry run, and then it checks all the logs, and then it checks which ones were which string had a match and which ones were missed. So you can evaluate those, and it helps you set the threshold, and it also gives you a recommendation based on the 95th percentile of valid history. And there's this the guardrail thing that I mentioned earlier. So sometimes the embedded model tells you, okay, so for this string, this is really similar, so use this. But then it's just like completely different. So there's a guardrail which basically requires minimum one word match, because if the two strings don't have any words in common, then the chances are it's just noise. But in case if the meaning is very, very close, then it would have the distance of less than 0.15, or in the test data that I used. So there's this thresholds for the strict distance, and if anything is 0.15, then anything is let through, even if there are no word matches. Okay, and additional features. So some of them I already mentioned, but prompt override per language. So you can name your prompt with your language code, and you put it in a designated folder, and then that takes effect rather than the default prompts. So there are two default prompts. One is generic. So if no custom prompts are given, then that gets picked up. Or if your language code, the target language is Japanese, then that gets picked up. And yeah, and then you can supply yours. And also it comes with a glossary generator, because I assumed not all communities have glossary. So translation memory is easy to get hold of because you already have translated strings, and you just need to ingest it. And this glossary generator generates a glossary candidate from the translation memory that you ingested. And there's a script called demo_prep sh. So it downloads all the necessary files. So translation memory, glossary, and untranslated strings, all in Japanese. I added that so that the Japanese community members can try this out without much hassle. And then the RAG fine-tuning helper, post-processing framework, translation evaluation, these were what I mentioned earlier. Okay. And the caveats, maintaining RAG data quality is very, very important. So, yeah. So if you think adding lots of data is going to be useful, think again, because it's basically garbage in, garbage out. So you really need to decide what to add and what not to add to the to your vector DB. And you also need to adjust threshold after adding about 5,000 strings, because after adding about 5,000 strings, then vector dilution may happen. So you need to, with your existing thresholds, it may not filter out noises correctly. So what's next? Feedback and conversation. So I'm accepting feedback, and I also want this to be a conversation starter within the wider community. You know, if everyone thinks this is a bad idea, you know, we can maybe build another tool. But I think using RAG and LLM is useful for string translation. And also add a token counter, because I burned quite a bit without knowing how much I was actually using. And support non-OpenAI API endpoints. That would be useful, probably. TMGMT integration, that would probably be useful, I think. And with the RAG proxy, it's going to be relatively easy to implement, touch wood. Transitioning from local execution to cloud infrastructure. I built this with the assumption that this will always be running locally, but especially with something like TMGMT integration, multiple people may be using it, so having it on the cloud might be useful. And last but not least, French translation for localgov Drupal, localgov Drupal is a distribution and install profile for local government, which was built in the UK, and it's been massively successful, and it entered entered into France, and fine French gentleman Renaud Cooney, who's also my former colleague, is translating localgov Drupal into French. And possibly using this, so he's playing with this RAG LLM translator to translate it into French. And he's also apparently building this tool that compiles glossary from publicly available sources, and then he's thinking about plugging it back into this, so it's exciting. By the way, I don't want to name drop, so this tool is not endorsed by Localising Drupal or anything, but Renaud is using it, trying it out. So that's it. Thank you. Sas efharisto. Arigatou gozaimasu. I don't know if we have any time for questions, but maybe it's the end of the day, so yeah, if you have any questions.
5 minutes.
Yeah, 5 minutes, okay. Well, if anyone has any questions. By the way, I have a question. Is anyone interested in running this locally and want to know more about it? Because I'm happy to help. And if there's any interest, maybe I can set up a BOF, or if you want to have discussions about this, I can, I'll set up a BOF. So raise your hand if you're interested. Okay. Well. 3 people, maybe. Yeah, let's catch up after the talk, and then we'll decide how to do it. But yeah, all right. Thanks. Any questions? All right. Well, thank you very much, and have a lovely day. And maybe I'll see you at 9 o'clock at Banana something. All right. Thank you.